Jury duty. Okay, today we're going to look at rotavirus. One of the reasons we're not going to cover enteric colobacillosis, Dr. Kopich is going to cover some of that. I cover a lot of this when I talk about pigs. The other one is Lawsonia intracellularis, which I also cover with pigs. So rather than go over them twice, what I will do is when I talk about pigs, I will give you the distinctions between pigs and horses and some of the symptomatology. Pretty much the diseases run the course pretty much the same way in both species. Okay, what rotavirus? One of the most common fungal diarrheas that we have out there. And we see it everywhere, any place there are major breeding centers, any place there are foaling out farms. In of itself, the disease is not, how can I say it? It can be fatal and will be fatal if the appropriate supportive therapy is not given. And in this case, because it causes such an explosive diarrhea and it does affect the villi within the intestinal tract, these animals need fluid replacement therapy as well as electrolyte replacement therapy. And in some cases, if they are losing protein and plasma, is also needed and needs to be given. Farmers may manifest the disease as both a single case, a single outbreak, or you can have several outbreaks on the farm. It is highly, highly contagious. There is, just to jump to the chase, there is a commercially prepared vaccine available. But what helps most importantly with controlling rotavirus, enteritis and colitis is good hygiene. So cleaning between stalls. Now the problem with it, all of us are kind of convinced that people spill everything, right? Doesn't touch rotavirus. As a matter of fact, most of our more common disinfectants don't do anything with rotavirus. So we have to look at peroxide-based cleaners as well as phenol-based cleaners that are most effective in terms of disinfecting. As far as bedding from contaminated stalls, that needs to be taken out, either buried or composted. And with composting, what happens with composting? Any of you who have gardens, what happens when you compost something? It gets hot. And that's one of the reasons composting is so popular, because it does. I mean, you look at what you're composting. You're usually composting decaying matter, and you obviously know that there are bacteria as well as harmful microorganisms within the compost. So once the compost reaches a certain temperature, we get kill off of parasites, we get kill off of bacteria and other harmful microorganisms. So we can compost it, we can also burn it, and burying it. It's just going to depend on what the local ordinances require you to do with it. The virus belongs to the Reoviridae family. And that family is, or I should say the genus rotavirus is subdivided into several groups, A through G. And that's going to be based on the differences in the group, as well as specific capsid proteins. And that specific one is B as in verify, P as in Pam, and 6, BP6. Equine and other animal isolates are located in group A. Groups B through G cause disease in humans. Swine, fowl, and other animals. So equine, which is pretty simple to remember, is mostly associated with group A. When we talk about the VP groups, that specific intercapsid protein, there are other capsid proteins such as VP4 and VP7. And the reason we bring this up is they are important in terms of manufacturing a specific vaccine. So VP4 designates our protease sensitive. VP7 is just glycoprotein serotype G. So the strains of rotavirus are also named based on their G and P genotypes. And I'll just let you guys write that slide down. It's got a lot of information. There are at least 7 G serotypes and 6 P serotypes that are associated with horses. G3P, G14P are the most prevalent in foals, so put an asterisk by those two because those are the ones that we see most commonly in foals. G3P and G14P serotypes are among the most prevalent seen in horses. So put an asterisk by it. The others kind of like an FYI, but the ones that we are most concerned with are those two. As I've already previously mentioned, rotavirus is pretty hard to kill in the environment, so they cannot be inactivated by our normal disinfectant. Bleach is pretty much the main one, or hypochlorite, that we tend to go to when we're talking about disinfecting. Salmonella can be inactivated by, E. coli can be inactivated by bleach, but rotavirus cannot. So our other products would be ethanols, phenols, and formalin, and obviously we don't want to install formalin. Even though at one time they did go in and kind of aerosolize formalin and use it as a disinfectant, but obviously that has kind of toxic implications, especially if you happen to be the one in there and inhale it. Rotavirus is pretty much considered species specific. Do you see rotavirus in adult horses or only in foals? We see mostly occurs in foals. There is no natural reservoir. So unlike a horse that breaks with salmonella, where we already know that salmonella is a normal part of the bacteria within the equine, you just happen to see clinical symptomatology when an animal is stressed and we get overgrowth of salmonella. And one of the things that also makes rotavirus hard to get rid inability to be, or its ability to be, not to be inactivated by, your more common disinfectant is the fact that this organism can stay viable for up to 9 months in the environment. Factors that may lead to disease outbreaks on a farm are going to be stocking ratio. You have a whole lot of mares with foals out there. And if you do have an animal that has rotavirus, how much of that infectious agent is being pushed out into the environment? It is transmitted through the fecal-oral route. Has a very short incubation period, 12 to 24 hours. So that would be one thing that might help you distinguish it from salmonella. Salmonella has a little longer incubation period, and you see many prodromal signs in horses before they go with diarrhea. With salmonella, you may see 36 hours and get up to a week. And some of these horses manifest colic-type symptoms, and the stool may be out. But with rotavirus, you have a really short, really 12 to 24 hours, and you have voluminous amounts of watery feces. During outbreaks, mares or no horses are not clinically affected. However, you may have some mares that seroconvert, which makes them subclinically infected. What would be the implications of subclinical infection in a mare? We know mostly this is a foal-related disease. What would be the implications of subclinical infection in a mare? No, it would be, think about it. If I have a mare that's subclinically infected, and I don't have anybody else on the farm, or I'm bringing, you said? No? No. Okay, when I say something is subclinically infected, are we saying symptomatology? No. So what do they usually serve as? Carriers of the disease, right? So if I've got a mare that is subclinically infected, and I've got a farm, a broodmare farm, and I'm getting mares in to foal out. So I've got this 1 or 2 mares that have seroconverted. And they're passing feces wherever they go out in the pasture. And I've got mares that have foaled out, and once they foal out, they're out of the stalls and back in the pasture. Remember, it's fecal-oral contact. What do we know about foals? They're corpophagic. Okay? So if I've got a subclinically infected mare, she's going to be the source of my future outbreaks on that farm. And once I have a foal that's going to be infected, with the foal I am going to see clinical symptomatology. Okay, the average age of affected foals is 75 days. So you have a pretty good age range. So anywhere from 2 days up to 155 days. Foals that are older than 1 month of age are significantly more likely to have rotavirus as compared to younger foals. Average duration of the diarrhea is about 3 days, even though you can have some at the extreme go up to 9 days. Remember, they never read the book. And each time they defecate, they shed viral particles. And again, as I said, the disease in of itself is not, they get it, they die. The problem comes in is because these foals become so severely dehydrated, acidotic, hyponatremic, hypochloremic, hypokalemic, that they die, okay? So we have to replace electrolytes as well as fluids, as well as correct the acid-base balance. It has a high morbidity rate, meaning there are a lot of sick foals, but a low mortality rate. But that can switch around too if we don't follow good disinfection protocols, and if we really don't jump on a foal that has rotavirus or has an infection. What are some of the other things that may happen to these foals with rotaviral infection, other than the ones I just mentioned? What happens to a sick diarrheic foal? What other things are they susceptible to? Well, I've already mentioned dehydration, so you can't mention any of that. What other? Well, I already mentioned that one. No, just, okay, now you're trying to be specific. Secondary bacteria, they don't have low blood sugar, no hypoglycemia, that these folks got the same because they haven't absorbed anything. So, secondary bacterial infection. Remember, if I have a septicemia, if I have a fold that's down, it's compromised, they are more susceptible to developing secondary bacterial infection as well as septicemia, okay? So it's not just, I need to take care of that and all the other things. We need to be judicious in monitoring that fold and seeing what's going on. Shedding of the virus, once the diarrhea is resolved, we don't have any more shedding of the virus. So basically, once it enters the GI tract, it multiplies within epithelial cells of the villus tips. So you get a duodenitis, jejunitis, basically an enteritis. And when the villi become affected, what happens? What kind of diarrhea would this be, looking at the symptomatology? Non-absorptive, secretory, osmotic, what else? What happens if the villus atrophy are messed up? What kind of fold is? They can't absorb. So you get some malabsorption, but you get some osmotic too. So with the organism multiplying within the villi, it destroys them ultimately. So we basically have an animal with an enteritis that is unable to absorb nutrients. Lactase is also affected. And we also end up with an osmotic diarrhea because we are losing some of these disaccharides. So we have a lot of different things going on with these foes. So in treating this foal, what would be, obviously the first thing we need to look at is the foal's hydration status. We need to look at its electrolyte status. So we're going to give, obviously, IV fluids. We're going to do replacement fluid therapy, replacement electrolyte therapy. How are we going to correct the acidosis? We're going to get bicarb. So, that's going to probably be a test question. I'm probably going to give you an acidotic animal, and you're going to show me you know how to correct the acid-base balance in that animal. So I'm pretty sure you could have covered that in point half. So go back and review it. Laugh about it now, but guess what? When you get into the clinic, which you are in there now, and we have horses that present like that, or you have dogs and cats, you need to be able to know how to correct it. There are formulas for all those things. Okay? Okay, intestinal, yes, ma'am.
Specific method that you would prefer us to use, or?
There is no specific method. You either know how to correct after face balance or you don't. It doesn't change. You need to know what you need to know. If I tell you I have an amylase diuretic that's 25% dehydrated, you better be able to calculate out fluid therapy. And if I turn around and tell you it's acidotic, and I give you some numbers, you better be able to know what to do with those numbers. Okay? I'm not gonna tell you